Hello everyone. So today we're going over 3.2 polynomial functions and their graphs. So last time I gave briefly the definition of the polynomial function. So I said a polynomial function here, a polynomial function of degree n is a function of the form f of x equal here f of x or b of x. So the polynomial function is a function of this form b of x, here bn of x. This n is mean the degree of the polynomial function. So bn of x equal an x to the power n plus an minus 1 times x to the power n minus 1 plus dot 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 plus a1 x to the power 1 plus a0. an minus 1 to a1 a0, all of them called coefficient of this polynomial. So all of these, all of a's are the coefficient of this polynomial. And also we should to know this n is a non-negative integer. This n is a non-negative integer, and we should to know an here is not equal 0. So we have two conditions. N is non-negative. Hold on 1 second. So this n is non-negative integer. Also, we have to know an here not equal 0. Okay, so an to a0, all of them called coefficient. Here. Coefficient. This a0 is called the leading, the constant coefficient. And here an called the leading coefficient. This an only, this called the leading coefficient, is the leading coefficient. Just I define this because we're going to use this definition during this class. I mean, I don't need you to I need you to understand when I said leading coefficient mean the an. When I said a leading coefficient during this class, this is mean the an, the coefficient of the x to the power n. And this called also, I'm going to use this definition also, the leading, the constant coefficient. Constant coefficient. Also, it's called the constant term at the same time. Also called the constant term. This called the constant term also. And this here with the x, with a variable called the constant, here the leading term. So when I said the leading term means an x to the power n, such that n is the degree of this polynomial. Okay. Now we have to know how is the graph of the basic polynomials. This is just a review. Before we go to the graphs, any question for this? Or this clear? I'm going to give you example before we're going over the graph. So for example, if I have a polynomial of this form, b of 4x, so I can write it as any like minus 5 x to the power 4 plus 2x to the power 3 minus 7x plus 3. So this polynomial has a degree 4. Why 4? Because this is the highest exponent of inside this polynomial. Number 2, this minus 5 here is called the leading coefficient. This is the leading coefficient. Leading coefficient. And this 3 is called the constant coefficient. Okay. Now the degree for this is the highest exponent. The highest exponent is 4. We have 4, we have 3, we have here 1 actually. Here we don't have, this is mean x to the power 0. So the highest exponent is 4. So the degree is 4. Okay. What is the leading term? What's the leading term here? X to the power 4. This is correct. X to the power 4 is the leading term. So here, leading term, the leading, no, it's not x to the power 4 only. It's not x to the power 4 only. What is it?
Negative 5x to the 4.
Yes, exactly, with the negative 5. This is correct. We have to multiply by the negative 5. This is all, this is the leading term. So the leading term, the term is not, is minus 5 x to the power 4. This is the leading term. All this. What is the constant term?
3.
Exactly, only 3. The constant term is 3. The constant term is 3. Yeah, this is what you should to know. Okay, any question for this example? When we say the leading coefficient, that is x to the power 4, the leading coefficient, it's the coefficient, the number in front of the variable x. When we say the leading coefficient, that is minus 5, yes. The leading coefficient, it's minus 5, is the coefficient of x to the highest power. What is the highest power? Is 4. So the highest power is x to the power 4. The coefficient, the number in front of x to the power 4. And when we say term, that is, yes, term everything. Mayesha, this is, yes, it's everything with the number. Okay. But for the constant term and the constant coefficient is the same. Constant term and constant coefficient is the same, 3. Both of them 3. Now we have to know the graph of the basic polynomial functions. Graph basic polynomial functions. So first of all, let me give you a review. So we know the basic polynomial. For example, a polynomial b of x equal x. This is a polynomial. What is the graph of this function? This is just a review. What is the graph of this function? So at 0, if I plug the 0 inside this function, b of 0 equal what? 0, right? At 0 is 0. So the point should be here. At 1, b of 1 equal what? 1 will be here. At 2, give me 2. At 3, 3. 4, 4. It's a linear, exactly safe. It's a linear function. This is a linear function. So the graph of this should be like a line. And in the same time, this is a polynomial function. So this is the linear function. This is the graph of the function. It's a linear function. And the graph should be like this, line. Okay? So this is a linear function. And also it's a polynomial function. Okay, this is a basic, like the easy one. Now, what is the graph of the function, number 2? b of x, polynomial of x squared. So x squared is a quadratic function, as we learned before. It's a quadratic function, x squared, as we learned in the previous section, 3.1. This is a quadratic function. It's a parabola, yes, exactly. Also, in the same time, is a polynomial function. Also, it's a polynomial function of degree 2. So it's a quadratic function, as section 3.1. The graph is a parabola. Yes, the graph of this function, it's look like a parabola. So the graph of this function should be like this. This is a parabola, like this. And also in the same time, this is x squared. X, p of x, here number 3, b of x equal x to the power 4 has the same thing. Parabola, open upward. But the different about the x squared, it's open more, is close to the, like it's shrinking, like it's closing to the 0, like this. As you see here, it's more open than this. This is like more closer like this. This is the graph of the x squared. But the graph of the function x to the power 4, it will be like more open, like this. And the same things for any b, or the same things for bx equal x to the power 6. This is mean any function of this form, b of x equal x to the power n, and this n is even number. What is the even numbers? Anyone can remind me what is the mean of even numbers? Two, 4, 6, 8. Exactly, Eric. Thanks. 2, 4, 6, 8, whatever, 10. All these numbers is even numbers. All of them have the same shape. Yes, even parabola, exactly. But when at 0, if you're looking at 0, it will be like parabola, but the difference between this parabola and this parabola, here at 0 like would be more open, close to the x-axis, but here will not be more open. Understand? Okay, the same things for x to the power 6 and x to the power, like any number, x to the power 8, same things. Now, for x to the power 3, like if I would like to graph the function, here number 4, b of x equal x to the power 3 should be like, we have to know the graph of this one because it's a review. The graph of this function is look like this. So the greater, close to the 0, will be more closer to the 0. So this is b of x equal x to the power 3. Same things will be like close to the 0. It's openable 0 like this. This is b of x equal x to the power 3. But if I would like to graph number 6, I mean number 5, b of x equal x to the power, for example, 5. So it's going to be the same things, but will be like open at the 0, like this. The graph should be like open at 0. Like this. Close to the 0, more and more. So when b of x equal x to the power n, and this n is odd number. What is the odd number? Odd numbers. What is the odd numbers? Which number is odd or odd? 1, 3, 5, 7, 9. Exactly. Thank you. 1, 3, 5, 7, and 9. All of this is odd number. So the graph would be like have the same shape. All of them have same shape. So look, this is a polynomial. Okay, so now we're going to use the transformation to graph the basic polynomial. So my example now, I'm moving to the next slide. So my example, graph the following function by using transformation. So I'm using the transformation to graph this function. So number one, the function is, so number one, b of x equal minus x to the power 3. Here is Eric. Okay. So my function graph the following function by using the transformation. So first of all, this function is polynomial function. And we have to know what is the original function before we start solving this one. I mean, graphing this one. What is my original function, O of x? Yes, function. Now I have to modify in this function to make it similar to this. What I should do? I have to multiply by what? By -1, exactly, thank you. So I have to multiply both sides by -1. Now I will get minus O of x equal minus x cubed. And this is the same as this one. And this one is b of x. So this is equal b of x. So actually b of x equal minus O of x. Okay, so this is mean to graph the function, to graph the b of x, I should to graph the original function O of x. My original function is x cubed. Then we have to multiply by minus. What does this minus mean? When we multiply the minus outside, what does that mean? When I multiply the minus outside of the function, of the original function, can someone remind me what does that mean? Sometimes we multiply the minus inside the function, I mean inside the parentheses, and sometimes outside. Yes, Jolene, this is correct. Thank you. So we have to reflect the original function around the x-axis. When we multiply the original function by -1, The minus is outside the original function, mean we have to graph the original function. Then we have to reflect it around the x-axis because the minus is outside the function. So here is the original function. This is x cubed. This is my original function. O of x. Now, second step, we have to multiply by minus. This is mean we have to reflect it around the x-axis. So my mirror now it's the x-axis. Here is my mirror. Now all points should be reflected here. So at 0 should be the same point. This point should be here. This point should be here. And the same things for all another points. So the graph should be like this. And this side, the same things up. This point should be here. This point should be here. This point, same. So all graph should be like this. This is the function of b of x. The blue one is b of x equal minus times O of x. Any question? Any question for this? Okay. So now we're going to graph. This is the basic. Now we're going to graph any polynomial, not just the basic. We have some steps. We're going to use it to graph any polynomial function of degree 5, of degree 7, of degree 8, any polynomial. So, but before we're going to graph the polynomial for any degree, so we're going to talk about the important things is the end behavior. The end behavior is the way to graph any polynomial function, or it's the method to help me to graph any polynomial function. So here I can say graph of polynomial functions and behavior. And behavior. Okay. So first of all, we have to talk a little bit about the end behavior. So I mean, for the end behavior, this is very important to help me actually to graph any polynomial function. So here, suppose, so I can say here the end behavior, the end behavior of polynomial suppose my polynomial is b of x equal an x to the power n minus n plus an minus 1 x to the power n minus 1 plus dot 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 plus a1 x plus a0. This is my polynomial function. So the end behavior depending on the determined by the degree of n and the sign of this, the leading coefficient. So actually the end behavior determine by two things. One, the degree, n. What is the degree? It's odd or even, whatever. Number two, the sign of the leading coefficient of an, this one, positive or negative. This is what I mean, the sign of an. It's a positive or negative. So I'm going to start for the first one. Suppose my b of x, this b of x, do you see this b of x? This is the same one here. So has odd degree. So b of x has odd degree. What is the meaning of odd again? 1, 3, 5, 7, etc. Degree. What is the meaning of degree? What's the meaning of degree? Exponent. But which exponent is this? An exponent in the polynomial?
Cn.
What is that?
Is it
Tn?
the n at the n value, maybe?
Yes, n. But what is, like, why you choose n? Why you did not choose n minus 1? The degree is the highest exponent. Yes, Jeline, this is correct. The highest power, not any power. The highest one, the highest power is odd number. Okay? The highest one. It's n sometimes, but sometimes it's n minus 1, whatever. Doesn't matter. So I mean for degree, the highest. Power. So the highest power is odd number. So the end behavior will be like this. So here an is positive. An is the leading coefficient. The leading coefficient. I mean for the leading coefficients, it's the coefficient of x to the power n. It depends. X to the power the leading, I mean. X to the power the highest power. An is the coefficient of x to the power the highest power in the polynomial. So if an is positive, so the end behavior when x goes to infinity and when x goes to minus infinity, this is the end behavior. When x goes to infinity, the y should be goes to infinity in the same time. When x goes to minus infinity, the y goes to minus infinity. So the graph, small graph for this. Here is my polynomial. So it's supposed to be like this. So as we see here, when this x goes to infinity, become large and large, the y value become large at the same time. It goes up, as you see. And the same things for the negative side. If x goes to minus infinity like this, the y value goes to minus infinity. Okay, for the second case, for this one,
Professor, can you just explain that one more time, please?
okay, again. So first of all, b of x has odd degree. This is my b of x. If the degree, the highest power in this polynomial is odd number, and the leading coefficient is this. This is the leading coefficient. It's the coefficient of the variable raised to the highest power. If this leading coefficient is positive and the degree is odd, the end behavior when x goes to infinity, look, x goes to infinity like become the value, the variable x become large and large, goes to infinity. The y value for the graph will goes to infinity, goes up. Look to the curve. This curve goes to infinity, goes up. And the same things when x goes to minus infinity, like this side, the y value goes to minus infinity, goes down. Goes down means the y goes to minus infinity. Large negative number, like -1, -2, -3, -4, -5 to the minus infinity. Okay? I hope it's clear now.
Okay, thank you.
So when an is negative number, this is for positive number. Now when an is a negative number, the coefficient, the leading coefficient, I mean, is an is negative number. This formula when the power is odd, yes, this is for odd only. We did not talk about even. We just in the odd. Now when the leading coefficient it's negative, look what's happened to the end behavior. The end behavior. When x goes to infinity, the y, and when x goes to minus infinity. So we have two cases, x goes to infinity, x goes to minus infinity. When x goes to infinity, the y should goes to minus infinity. When x goes to minus infinity, the y goes to infinity, to the positive infinity. I'm going to graph to show you how is the end behavior here. So here is the graph. The function goes up, then here will be like this, then goes down. So as we see here, when x become large and large, look, x become large, goes to infinity. This is mean goes to infinity, become large. The y value become more smaller and small, goes down. Look, function goes down. And when x goes to minus infinity like this, the y value become large because the curve goes up. Is it clear? If you don't understand, I can explain it more. and again. Yeah, it's confusing. You should to memorize all these rules. Again, the coefficient is positive. First of all, here it's fixed. Degree of the b of x is odd. The coefficient is positive when x goes to infinity, when x goes to minus infinity. So when x goes to infinity, become large, the y value become more large. When x goes to minus infinity, like mean the x become more smaller and smaller, the y value also at the same times become so small. Same things here. When the coefficient it's negative, we have two cases: x goes to infinity and x goes to minus infinity. When x goes to infinity, the y goes to minus infinity because the curve goes down. And the same things here when x goes to minus infinity, so the y value become a large and large, goes to infinity positive. This is the first one for the odd degree. Now for the even degree. B of x has even degree. Again, what is the even degree? What is the even numbers? Anyone can remind me? 2, 4, 6, exactly. 2, 4, 6, 8, 10, etc. All of this is even numbers. Now, we have two cases. The first one when an, the leading what coefficient? When an is positive, so the end behavior for this, when x goes to infinity and when x goes to minus infinity. So when x goes to infinity, the y goes to infinity. When x goes to minus infinity, y should have goes to infinity again. So the graph of this function will be something like this. Look to this curve. When x become large, the y value becomes so large. When x becomes small, here x is small, right? The y value also become large at the same time, goes to infinity. Any question for this case? Now for an less than 0. Now for an is small. Here I get the question, which part of is small? Which part of x? Which part of x? When x become large, infinity, this is large. When x goes to infinity, this is mean when x become large. When x goes to minus infinity, this is mean when x becomes small. This is small, but this the large. Positive infinity large. In the graph, okay, this is the large. This is the small. For the large, when x goes to infinity, this is the large. Here's the x increasing, going to infinity. The y value also at the same time goes to infinity. This is the large. The small, this is the small side. When x goes to minus infinity, the y value becomes large. Same time. Okay, now this is for the small one. Yeah, this is for the positive. Yeah, this is for goes to x goes to positive infinity, and this is goes to minus infinity. Now for the small one, the end behavior here when x goes to infinity, when x goes to minus infinity. So when x goes to infinity, the positive infinity, so this is mean the y goes to what? And here the same things, y goes to. So when x goes to positive infinity, the y will be goes to minus infinity. And the same things when x goes to minus infinity, the y goes to minus infinity. And the graph of this one is this. So look to this curve. When x goes to infinity positive, this is positive infinity, the y will be positive. Here when x goes to negative, so the y will be negative. Again, this side in the above here, this is when x goes to infinity positive. Here when x goes to minus infinity. Any question for this, both of them? Like this. Okay. What's the functions of these graphs? The function of the, or it's a random. It's a random. I'm going to give you example to show you what is the function. So example now. So if you need example, like simple example for this, the first one, x cube. P of x here, for example, if you need example, b of x equal x cube. This is the basic example. The graph of this one is the same like this. This is a simple one, basic. B of x equal x cube. And the same graph like this. But if you need more harder, b of x equal x cube plus 3x squared plus 4x plus 2, for example. This is an example for this polynomial. Or you can get b of x equal x cube for x cube, for example, or minus 1 or minus 2, x cube plus 3x squared minus 4, for example. This is the graph. We can find the end behavior for all these functions. Degree for all these functions is 3. And we can determine what is the end behavior by going back to the a of n, the leading coefficient. Okay, now for the second one, if you need example for this, b of x equal x squared. This is the basic one. And I know how to graph the x squared. It's look like this. This is x squared. Also, another example is b of x equal x to the power 4 plus x to the power 2 plus 3. This is also another one. B of x has even degree. Another one, b of x equal what? Minus 5 x to the power 4 plus x squared plus 3x plus 2. All of them are working same like this by using the same end behavior for this, because all of them have, hold on, yes, all of them using the even degree, all of them using the even degree. And also we're looking at the leading coefficient. The leading coefficient here is what? What is the leading coefficient here? 1, exactly. What is the leading coefficient of the second one? 1. What is the leading coefficient for this? Minus 5, exactly. Correct, nice. So I get here a question about the leading coefficient for all of them is odd. Doesn't matter, odd or even, I don't care. The things I have to care is the sign of the leading coefficient. What is the sign? Is it a positive or negative? Just you have to look into the sign. The sign, is it positive or negative? I don't care it's even or odd. The even and odd for the exponent only, for the power. Clear? So my question now, find the end behavior here. My example, find the end behavior for the function b of x equal minus 5 x to the power what? 3 plus 2x squared plus 4x. This is my polynomial function. B of x equal minus 5x to the power 3 plus 2x squared plus 4x. So my question now, what is the degree? What's the degree? Exactly. All of you are correct. Thank you. So the degree is the highest power. The highest power here is, here we have 3, we have 2, we have 1. So the highest number or the highest power is 3. So the degree is 3. What is the 3? Is even or odd?
Odd.
It's odd number, exactly. So here is odd. Now, what is the leading coefficient?
Leading coefficient is 3.
Is,
Oh, I'm sorry. The leading coefficient is negative.
yes, it's negative. It's 0. No, it's not 0. Someone said 0. Someone, the leading coefficient is this number. Yes, it's minus 5. Correct. What is the sign for this? Is it positive or negative? Oh, the
Negative.
leading negative, exactly. Or instead of writing, I will say a of n is less than 0. So odd and less than 0. So I'm going back to the rules. So odd and less than 0. So the end behavior, when x goes to infinity, the y goes to minus infinity. And when x goes to minus infinity, the y goes to positive infinity. This is the end behavior for my example. So the end behavior here. So the
So
end, yes.
the graphs have to be perfect, or just show the end behaviors and that's all.
Can you repeat what's your question?
Are there
When you
specific
graph,
coordinates, or we can just show the end behaviors and that's it for that problem?
yeah, you can show me the end behavior and that's it. But this is like to make sure, to explain, to make like to confirm what's your work. Sometimes if you did
Right.
not write this, you will get confused and you will solve this question wrong. I mean, like
Yeah.
it's better
Got
to
it.
write it because I don't want to get like, because if you write it, you will like solving the question correctly. If you did not write it, it's fine, but maybe you will solve the question wrong and you will lose points. Understand? That's why I write it. So the degree is a 3. The a of n is less than 0. So you have to use the rule. Which rule is that? You have to go back to the rules. We have 1, 2, 3, and 4. So we have odd. The odd, it has two cases. This first case, this is the second case. The second one, it's less than 0, and this is what I need. When x goes to infinity, the y goes to minus infinity. When x goes to infinity, and when x goes to minus infinity. So when x goes to infinity, the y will be goes to minus infinity. And when x goes to minus infinity, the y will be goes to positive infinity. So this is the solution. Again, if you want to write it, it's fine. If you don't, it's fine. If you don't want to write this in the exam or to solve the question, it's fine. But the problem, maybe you will get confused. So it's better to write it, to know which one you should to use. Any question for this? Do we have to draw the graph? I will teach you how we can draw the graph. But first of all, we have to learn what is the end behavior before we go over graphing any polynomial function. Do we graph it? Not yet, not now. I'm going to show you, just we have to know what is the end behavior before we go to the graph of the polynomial. I will give you another example to find the end behavior of uh, of the polynomial. So if my question now, if my example is, so example 2, find the end behavior for the function my b of x here, b of x equal, so my b of x equal uh, x equal minus 2 minus 2 x to the power 4 plus 5x cube plus 4x minus 7. Okay, first of all, what is the degree?
4.
It's 4. The highest exponent, we have 4, we have 3, we have 1. Here we don't have, so the highest one is 4. So the degree is 4. Is it even or odd?
Even.
Even number. So here is even number. Degree is 4, so it's even. Now, what is the leading coefficient? An. What is an?
-2.
It's -2. This is correct. -2 is positive or negative? What is the sign? Is it greater than 0 or less than 0? Yes, it is negative. So the its degree is even and it's negative. So even and negative, even, let me check, even and negative. So it's suppose when x goes to infinity, the y goes to minus infinity. When x goes to minus infinity, the y goes to minus infinity. So the end behavior, here the end behavior, when x goes to infinity and when x goes to minus infinity, here the y will goes to minus infinity and y goes to minus infinity. Is it clear? So this is the end behavior for this example. I think it's you should to know what is the end behavior for anyone. Just using the rules, you have to know what is the degree, what is the an. It is positive or is negative, and it's even or it's odd, and you have to go back to the rules. I mean, like you have to memorize these rules. Now we have to know how to graph any polynomial function. Here, a graph. Polynomial functions. Graph of polynomial functions. So we have steps here to know what is how to graph any polynomial function. So the first step, number one, you have to know what is the zeros for the polynomial. So number one, you should to know what is the zeros for the polynomial function. Number two, you have to check the test point. I'm going to explain the test points. Number three, we have to find the end behavior. We talk about a lot about this. And number four, we have to graph. Okay, let me give you example, and we're going to use these steps to graph the polynomial function. So example, graph the polynomial b of x equal x plus 2 parentheses x minus 1 parentheses and x minus 3. This is actually, it's a polynomial function. Why? Because if I multiply this parentheses with this, and the answer multiplying by this will give me a polynomial of degree 3. The highest one is the polynomial of degree 3. So first of all, let's doing step by step. Number one, we have to find the zeros. What is the zeros here? What is the zeros? The zeros are 2 minus 2, if we, yes, exactly, Eric. Minus 2, if we plug minus 2 here, I will get minus 2 plus 2 will get 0, and 0 times anything here will be 0. So the first 0 is minus 2, and also 1. If I plug the 1 here inside this polynomial, I will get 1 plus 2, 1 minus 1, and 1 minus 3. And 1 minus 1 is 0, so 0 times this will give me 0. And the last one, b of 3, 3 plus 2, 3 minus 1, and 3 minus 3. 3 minus 3 will give me 0, so it's a 0 for this polynomial. Or you can solve it by using the zero product property, if you remember this property. So b of x, you have to say b of x equal x plus 2, x minus 1, and x minus 3 equals 0 by using the property ab equals 0, if and only if a equals 0 or b equals 0. So the same things here. Here we have a, b, c. This equals 0. This is mean x, the 0 for this would be minus 2. This make it equal 0. So, and solve it will give you minus 1, I mean positive 1. And this equals 0, I would get x minus 3 equals 0. This is mean x equal 3. So the third 0 is 3, exactly. So minus 2, 1, and 3. This is correct. So the zeros are minus 2 and 1 and 3. Second step, test point. So for the second part, number 2, we have to graph the line, the real line. Here's my real line. So this is my real line. We have to put the zeros that I found it in the previous one, number 1, and this line. So we have minus 2. Here is minus 2. Here we have the 1. And we have the 3. Here is the 3. Now we have to test the point. This is mean I have to pick any numbers greater than 3. What number would you like to use greater than 3? Pick any number greater than 3 and plug it inside the b of x and check what is the sign for the number. Is it positive or negative? Now pick any number greater than 3. For example, 5. Okay, I'm going to take the 5, like Safe said. Here is the 5. Plug this 5 inside the b of x. B of 5 equal 5 plus 2 is 7, right? So it will be positive. 5 minus 1 is 4 times positive. 5 minus 3 is what? 2. So positive. Positive times positive is positive. Positive times positive is positive. So the answer is positive. Makes sense? Clear? Makes sense? Is it clear? Okay. Now pick any numbers between. Can you explain that one more time? Okay, sure. Take the 5. Pick any number greater than 3. I take the 5. Plug the 5 inside the b of x. 5 plus 2, I get 7. What is the sign of the 7? Is it positive or negative? What is the sign for 7? Positive. So we put positive here. Inside the parentheses is positive. For the second parenthesis, 5 minus 1. What is the sign? 5 minus 1 is 4. What is the sign of the 4? Is positive or negative? Again, positive. And 5 minus 3 is 2. Is it positive or negative? It's again positive. So now you multiply positive times positive, like positive times positive. For example, 5 times 2. The 5 is positive and the 2 is positive. When you multiply any two positive, they will give me positive. So the answer will be positive. So the answer multiplied by this third positive, positive times positive, positive. So the answer is positive. We could choose the 4. Why did you pick the 5? We could, yes, you can choose the 4. If you're choosing the 4, the same things will give you positive. Mayasha. If you pick the 4, they will give you positive. You can pick the 4 and check. They give you positive. Now pick any number between 1 and 3. 2. Nice. Here is the 2. Okay, B of 2. 2 plus 2. What is the answer? Is 4. Is positive, right? 2 minus 1 is 1. And the sign of the 1 is positive. The third one. 2 minus 1, 3. What is the answer? 2 minus 3. 2 minus 3 is negative. Exactly, negative. Now, positive times positive is positive. And the positive times negative is negative. So the sign here should be negative. Clear? Now, pick any number between the minus 2 and 1. 0. Nice. Okay, plug the 0 inside the function. B of 0. 0 plus 2. 0 plus 2 is 2. The answer is positive. 0 minus 1. What is the sign? Minus. So it's negative, right? Yes, okay. 0 minus 3. Again, it's negative. So positive times negative is negative. Negative times negative is positive. So the sign here should be positive. Any question? Please ask. Now for the last one. Pick any number less than minus 2. Which one would you like to choose? Minus 3, nice. So let's take in the minus 3. Plug the minus 3 inside the polynomial. P of minus 3. Minus 3 plus 2 is minus 1, so it's negative. Minus 3 minus 1 is minus 4, so it's negative again. Negative. Minus 3 minus 3 is minus 6, it's negative again. Negative times negative is positive. Positive times negative is negative. So here is negative. Is it clear? So we find the second one. We test the point, we find the sign. Negative, positive, negative, positive. Now the end behavior. What is the end behavior for this one? So first of all, we have to know the leading term for this one is x times x times x is x cubed, x to the power 3. Okay? The leading term is x times x times x is x to the power 3. So number 3.
Wait, sorry, could you go back for a minute?
Yeah, sure.
Wait, I have a question. So do we just leave this like this?
Yes, we're leaving it like this. Now we're going to the third step, end
Okay.
behavior.
Okay, thank you.
Okay. Now the end behavior, we have to find the end behavior. So again, the leading term is x times this x times this x, so I get x cubed. So the leading term is x cubed, is 1 times x cubed. So my question is, what is the degree? What's the degree? And the an also.
So wait, how did you find the leading term?
Because if you multiply this 3 parentheses, you're going to get the leading term is the multiplying the first variable, I mean the variable inside this parentheses, times the variable inside this parentheses, times the variable inside this parentheses. So when you multiply the 3 variables, you will get x times x times x, x to the power 3. And because we have 1x, 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 so 1x to the power 3. Makes sense?
Yes, thank you.
Okay. Or you can multiply and check. When you will multiply this 2 parentheses, you will get like polynomial, and the polynomial you get, you multiply with a third one. So you will see also, so you will see the same things. The leading term is 1x to the power 3. So the degree will be 3. Exactly. And an is 1. So this is greater than 0. And this is odd. Odd, and the leading constant is positive. What does that mean? What is the end behavior? So when x goes to infinity, when x goes to minus infinity, what's happened to the y? What's happened to the y? So we have odd and positive. Here is odd and positive. Y goes to infinity when x goes to positive infinity. Y goes to minus infinity when x goes to minus infinity. So the same like this. So x goes to infinity, and when y goes to minus infinity, the y goes to minus infinity. Now we have to graph. So we should to graph. So to graph, we need this second one, and we need the end behavior. So first of all, when you graph, you have to, number 4, this is step number 4. I have to graph the Cartesian plane like this, and this is number 4. You have to put the zeros on the x-axis. So what is the zeros? It is 3 and 1 and minus 2. Eric, how did you find x to the power 3? I find it by multiplying the variable inside this parentheses with the variable inside this parentheses with the variable with this parentheses. So x times x times x, I get x cubed. And because in front of x is 1 times 1 times 1, I get 1x cubed, or 1x to the power 3. Okay, so now the zeros is a 3, 1, and minus 2. It is a 3. It is 1. And here is minus 2. Now, if it's positive, so the curve should be up, like in the above of the x-axis. Above of the x-axis, so the curve should be like this. It's a green color, so the green color like this. So the curve should be above of the x-axis like this, because positive. Now we have negative, right? This is negative, means the graph of the function should be below of the x-axis. So here is below of the x-axis. Below, like for this x, like this. Below of the x-axis. Now we have positive. This is mean above of the x-axis. So the curve should be like this. Goes up to the minus 2. So above of the x-axis. Now the minus mean below of the x-axis. So below of the x-axis should be like this. That's it. This is the graph of my polynomial function. And to check that this is correct by using the end behavior, look. When x goes to infinity, the y goes to infinity. Look, x become large and large. The y become large and large. The green, look, the green curve goes to infinity, positive. Goes to up to infinity. When x become small number, look, when x becomes small, minus 2, minus 3, minus 4, minus 5, to minus infinity, the y will be negative, goes down, 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 to minus infinity. So it's clear. Any question? Any question for this example? So you have to check the sign. If it's positive above of the x-axis, negative below of the x-axis, positive above again, negative down. And that's it. And you have to check the end behavior. When x goes to infinity, the y should be goes to infinity, positive, up. X goes to minus infinity like this, the y goes to negative infinity like this. Any question? Okay, another example. Graph the polynomial function. So the polynomial function is b of x equal x cubed minus 2x to the power 2 minus 3x. So let me do the steps. Number 1. Step number 1, find the zero or the zeros. So what is the zeros for this function? We have to factor, right? What is the factor for this polynomial? How we can factor this polynomial?
I think he should take out X.
Exactly, take out the x. Now I get x squared here minus 2x minus 3. What is the factoring inside the parentheses? This is parentheses. I'm looking for two numbers. The multiplication is minus 3 and the
Is
sum,
equal to 2.
what is
Or
it?
subtract equals to -2.
Negative 3.
-3. So is it 2 and 1? I think. No, it's 3 and
No.
1.
Negative 3 and 1, yes. The multiplication is minus 3 and the summation between these two numbers is minus 2. So minus 3 and 1 minus positive plus 1. Minus 3 times positive 1 is minus 3. And the sum between minus 3 and 1 is minus 2. So the zeros are exactly, Mayasha, 0 and 3 and 1, minus 1.
Quick question.
Yes.
Do we have to include the 0? Because I feel like in the past we didn't really include the
Yes, we should include it. We must include it.
okay.
The 0, the 3, and the minus 1. So step number 2, we have to find the sign. So we have to draw the real line like this. And we have to put the zeros in this real line. So the first 0 is, we have a minus 1 and a 0 and 3. Okay, pick any number between the 0 and 3. I mean, any number greater than 3. 4, for example, 4, exactly. So let's take in the 4. Plug the 4. So B of 4. The 4 is positive, right? So get 4 positive times 4 minus 3 is 1, so it's positive. 4 plus 1 is 5, so it's positive. So positive times positive times positive will give me what? Positive. Pick any number between 0 and 3. 2. Okay, nice. What is B of 2? 2 is positive. 2 minus 3 is minus 1. Minus 1 is negative. 2 plus 1 is 3. And the 3 is positive. Positive times negative is negative. Negative times positive is negative. Now pick any number between minus 1 and 0. Minus 1/2, clear, nice, minus 1/2. So what is the B of minus 1/2? So the minus 1/2, when you plug it here, I get minus 1/2, it's negative. Minus 1/2 minus 3 is a negative number. Minus 1/2 plus 1, it's positive. Why? Because the 1 is greater than the minus 1/2, so the answer is positive 1/2. So minus times minus is positive. Positive times positive is positive. Now pick any number less than minus 1. Minus 2, correct. Plug the minus 2 inside the parentheses, inside the polynomial. B of minus 2. Minus 2 here, it's minus. Minus 2 times minus 5. This is minus 5 because minus 2 minus 3 is minus 5. So minus times minus, here I get minus. and -2 plus 1 is -1. So the sign is minus. So the multiplication is minus times minus is positive. Positive times negative is negative. So the answer here, the sign should be negative. Any question for this? Now the end behavior. Number 3, the end behavior. What is the leading term? What is the leading term?
1.
It's 1 what? The leading term, not just the coefficient. Term,
Oh, x cubed.
x cubed. Yes, this is the leading term. 1x cubed. So the leading term is 1x cubed. So what is the degree? It's 3, correct. What is an?
1.
Is 1, exactly.
Greater
It's
than-
positive, right? Yes. So the degree is odd here. Odd and positive. Go back to the rules. Odd and positive. Here is the odd, here is the positive. When x goes to infinity, the y goes to infinity. When x goes to minus infinity, the y goes to minus infinity. So when x goes to infinity, when x goes to minus infinity, so here x goes to infinity, and here, I mean the y, and here is the y goes to minus infinity. So now it's easy to graph the polynomial function. So number 4, graphing. You have to graph the Cartesian plane like this and put the 0 inside on the x-axis. Here's the Cartesian plane. Okay, what is the zeros? It's here from the first one. It's -1, 0, 3. -1 and 0 and 3. Make it closer. It's like too much. So here's the -1. And here is the 3. So -1, 0, 3. Okay. So greater than 3 is positive. So should be something like this. So here is the green line, like this, positive, above the x-axis. Now negative between 0 and 3, below of the x-axis, below of the x-axis. So here is the below of the x-axis. Okay, for the third one, between -1 and 0 is positive above the x-axis, like this. Here is above the x-axis. And the last one is negative below of the x-axis. So here is negative. And that's it. This is the graph of the function, of the polynomial function. So to check the end behavior, when x goes to infinity, the y goes to infinity, look, goes up. When x goes to minus infinity, like this, to the negative side, the y goes to minus infinity, goes down. This is correct. So the graph of this function is correct. Any question before we leave?
No questions, Professor. Well,
Okay.
oh, just one thing, Professor. Anybody got 100 in the exam?
I don't know exactly, but most of the grades is good. I mean, some students they get 90s, 80. I don't know exactly. I forget actually.
I came a little late, so they're gonna be up.
Yeah. I will see. I will let you know next time. Okay. If it's someone gets 100. Okay. I will see you Thursday. Have a good day, everyone.
Oh,